Welcome to pre-lab lecture number 9. Lab number 9 is on types of chemical reactions and copper cycle. These types of reactions you have definitely covered in the lecture, and we covered in experiment number 4, chemical reaction 1, experiment number 6, chemical reaction 2, and we'll also look at in chemical reaction 3. Let me just start by sharing the screen and walk you through the calculation on the data sheet and where to get the material in order to successfully complete the data sheet. For now, I'm just going to share my screen, and you see I do have the PowerPoint slides and my whiteboard, experiment number 9, types of chemical reactions and copper cycle. I know you know the types of chemical reaction. Oxidation reduction reaction is one of them. Acid-base neutralization reaction, double replacement reaction, decomposition reaction, single replacement reaction, combustion reaction, and the combination reaction. The last two just stated, combustion and combination, you will not encounter in this lab. So that is just a type of reaction you'll encounter in lab number 9. And from the title, copper cycle, you will start with the element copper by knowing taking note of the mass and taking through a series of chemical reaction all the way to the starting point. In other words, we will start with the element copper and we will end up with the element copper at the end. You will perform calculation to determine the percent recovery. So that's all about our experiment number 9. These are the type of reaction I just went through. The last two are not covered in this lab, but the first 6 or so are covered in this lab, in the sense that as you take copper through the cycle, it goes through reduction, oxidation, acid-base neutralization, decomposition, single replacement reaction, and double replacement reaction. Please read the top head. In top head, there is the handout. Okay, don't rely on the PowerPoint slides. Only you still need to read the handout or the procedure on top hat. Now, at the end of the exercise, you will calculate the percent recovery by taking the mass of the dried copper of the original mass of copper in this experiment times 100 to get the percent recovery of copper. I want to say that there are 8 equations, all right? There are about 8 or not 8, but 13, about 5 equations you need to pay attention in the lab manual. In the lab manual, let me just show you the types of equations, or the kind of equation I'm talking about, from equation number 8 all the way to 13, all right? If you take note of equation 8, all right, or reaction 8, you're starting with the original copper. This is the copper. You take note of the mass, reacted with what? Nitric acid to form copper 2 nitrate. You should be able to, by this time, you should be able to write the correct chemical formula and name the compounds given the chemical formula. So this is called copper 2 nitrate, water, and of course, nitrogen dioxide. stoichiometry 1 to 4 to 1 to 2 and to 2. Now, as you go through, when you'll be completing the data sheet, you need to indicate the physical state of where copper is. Remember, we are keeping an eye on copper. This is the circle, all right? Let me just show you the circle by which copper will go through. I think it's below here. Let me just show you where the circle is. This is the cycle we are talking about, starting with copper. Reaction 1, it goes through this cycle. Look at where copper is all through, all right? If I look at this cycle right here, I don't see the physical state of, or I don't know the physical state, yet you will be expected to write the physical state of in which copper is in that form. For example, this could be solid, liquid, gas, all right, or aqueous. Aqueous means dissolved in H2O. So by looking at this circle right here, it will not give you complete picture on the status or the physical state. So what I want you to do is look at equation 8, 9, 10, 11, 12, and 13. It will indicate the physical state in which copper is in as you proceed with the reaction if you have to come to lab. For example, here, when you react nitric acid concentrated with solid copper, the copper will be in form of aqueous, all right, in aqueous form. So this is, maybe I'll write down the note that after this reaction, what is the form of copper is in aqueous form. If you move forward, it's also in aqueous form. That's just giving you that. When you add nitric or sodium hydroxide, for that, in which form is copper? This is in solid. Followed by addition of sulfuric acid, it's in aqueous form. That's equation now 12. And if you look at the last equation, equation 13, copper is in solid form. This is the last equation. I want you to look at those equations in which form is copper as you go through the cycle. You will be required to fill in that information or those information in the data sheet. One thing I want to point to you is also look at the what? Look at the PowerPoint slides. You got to look at the PowerPoint slide so that you know the color in which you have to indicate the color, all right? If you look at the cars forming, you should reconcile this with the data sheet, all right? Let me see the data sheet here, all right? Data sheet, if I look at the data sheet, this is cars forming. Look at the cars forming reaction. You should go with the demonstration on the PowerPoint slide so that you do what? You complete the data sheet here. 1, mass of the reaction beaker you are given here. Weight of the 100 ml beaker is 50.2348. It's just gonna be the mass of the beaker. Weight of the beaker with copper, this is where you will place in there. To get the mass of copper, you of course should be able to do the mass to get the mass of copper. And please take note of the physical state. When say physical state, it is not referring to what you weigh after the reaction. You need to read the procedure for cars forming reaction in the data sheet for 4.1. That is after the reaction. In what form is copper? Not before you react, after the reaction. This is where you will indicate the physical state, whether it is what? It is aqueous, whether it is solid, whether it is gas, all right, or liquid. By looking at equation on 4.1 cars forming, you should be able to write the physical state. Now the color, if you look at the cars forming right here, what is the color of the solution? That's what I'm looking for. And then of course, the chemical formula, look at the reaction. Follow the cycle. When you go around the cycle, once you perform the reaction on 4.1, in what form? What is the chemical formula for copper compound formed after the reaction on 4.1? You need to write that. And what is the chemical name? Where is copper? This should be the question. Where is copper? That means after the reaction, where did the copper went? All right. I don't want you to think that I'm asking for solid copper. No, everybody knows that. After the reaction, where is copper? It is in form of something else. That's what you need to do in 4.1. In 4.2, please read again the background procedure, acid-base neutralization, all right? pH of the solution, what the demonstration for 4.2, acid-base neutralization, all right? You'll have to wait the demonstration here. The instructor will tell you the pH of the solution. Please indicate that, all right? Molarity of sodium hydroxide, it should be in the background procedure, please. It is not given in there, but, all right, you will read the background procedure for the information on the molarity or concentration of sodium hydroxide, all right, pH, all right, the instructor will do the demonstration for the pH of 15 ml. Then after the addition of 10 more ml, you will take note of the pH. The information here will be obtained by paying close attention to the demonstration and listen to what he's saying. What is the pH? Okay, that's what you will do. After that reaction, you'll ask yourself, all right, after addition of 10 ml NaOH, sodium hydroxide, where is copper? Unless you read the background procedure top hat, you will not be able to just look at the PowerPoint slides or listen to what he's saying and just be able to do that. You have to supplement this with the background procedure to indicate the physical state. Look at the equation. What is the color, all right? Indicate the color of the solution, where copper is, the chemical formula, and the chemical name. If you don't give me the physical state, as it should be, you'll get it wrong. If you don't give me the chemical formula and the chemical name, if you get it wrong, all right, you lose point for that. So for this information, I'll recommend that look at the what? The demonstration as well as the background procedure in the manual, Decomposition reaction, okay? Decomposition reaction be given here, all right? Decomposition reaction is demonstrated right here. What is going on? Gotta come here and write the physical state, where copper is, the color, chemical formula, the chemical name. You do the same thing for double replacement reaction, all right? Double replacement reaction, it follows the same procedure. I don't want to play the decomposition reaction. This one you can play your own and listen to the instruction given. Double replacement reaction, this is the demonstration. You have to pay attention to what he's talking about, the color of the solution, all right? Once you have all the sulfuric acid in here, what is the color of the solution? What is the chemical formula? You'll indicate that. Mass of the evaporating dish, all right? You got to place that at the top right here. This is the mass of evaporating dish. Mass of sink use, I think it was on the previous slide. All right, let's see, mass of the zinc. I think it's given somewhere. You'll be given the mass. You see total mass of zinc added. We need to take note of the mass of zinc used. So place that. Let's see, after drying, all right, this is the mass of, not there, but below here, these are the information you need to fill in the last, all right, the last column right here. I mean, 4.5 single replacement. This is the final weight of the recovered copper and evaporating dish. Mass of dish and dried copper is given here. It's going to be on this line. Mass of the zinc use is, I showed you earlier on. How do we get the mass of the recovered copper? Will be mass of the dry copper and the dish minus just the mass of evaporating dish. So 4.4 here is the evaporating dish by itself. And in 4.5 or 4.5 here, mass of the evaporating dish dried copper, you subtract this will give you the mass of dried copper. In our percent recovery here, this line 2 here will be at the top, mass of the dried copper. The original mass, all right, the original mass will be given, all right, the original mass will be given by line 1. Line 1 will be the original mass of copper times 100%. You need to ask yourself by looking at the equation, all right, by looking at the 5 equation or so to complete the last table right here. Where is copper physical state? That's after doing everything. Look at the equation as a hint. The physical state, the color, chemical formula, and the chemical name, all right? Other than that, please show your calculation, all right? You need to show your calculation. Otherwise, turning in just only tables with no calculation, you will lose points. Please attach your calculation. We will meet again on Thursday. Please plan accordingly to the pre-lab for next lab, which is envelope of reaction. Other than that, thank you. See you on Thursday.